About congruent triangles, we are going to be making some congruency statements. Congruency means the same size and same shape. Today we're looking specifically at triangles. Congruency itself isn't that difficult. What makes congruency a little bit difficult is trying to organize the information. So being able to say what the length of one thing is based on the length of something else. Let's start by just looking at a very basic shape. I'm just going to make a triangle that is 3 by 4. And then I'm going to make a triangle right next to it that's also 3 by 4. If you don't have graph paper, just make it close. It doesn't have to be perfect. And then what I'm going to do is I'm going to label my corners A, B, C. And I'm going to label these the same way, so A, B, C, and then I'm going to label this one D, E, F. So in this particular case, I've got a triangle, and I'm going to call that triangle A, B, C. And that triangle is going to be congruent to triangle. My A is my top corner here, so that'll be triangle D, E, C. Notice that congruency symbol is like an equal sign with a little squiggly mark. D, E, F, sorry. Yeah. So the congruency mark is that little equal sign with a little squiggly mark up above it. And we're always looking for the things that match. So this corner right here matches this corner right here. This corner right here matches this corner right here. We can use the same symbols that we used in our last section when we dealt with classifying triangles. So like that side right there matches this side right here. This side is our second longest. And then this side is our third longest. Yes, ma'am. Right, she just made an interesting point. She said, what if we said that we had triangle, you said ACB is congruent to, so now our triangle, that's a triangle sign. So triangle ACB, so we're going from here to here to here. The triangle that's similar to that is going to be the same order. So it's going to be D, F, E. The reason that those are congruency statements is because this angle right here is the same angle as that one right there. This angle right here is the same as that angle right there. The distance from here to here is the same as the distance from here to here. So those congruency statements here describe these triangles up here. So that's a really good point, Natalia. Let's look at another example. Let's say I've got a triangle and it looks like this. Yours won't be exactly like this, but close is fine. And let's say it's L, A, S. Now, I don't think these triangles are exactly drawn to scale, let's have triangle ABF is congruent to, now see what we did here is we kind of moved our second triangle. In our first one it was pretty easy because they lined up really easily. In this one we have to pay a little bit more attention to where that angle is located in our original. So in our second triangle, we've got triangle, and we've got the A right here. Which angle in our second triangle is going to correspond with that angle right there? Scout?
L.
Why do you believe it's L?
Because
So it's got that A has 3 marks, so the L has 3 marks. There's also other things that we can use. The A is the one that's in between the 1 side and the 2 side. The L is also the one in between the 1 side and the 2 side. So L is our first angle. B is the second one in our first triangle. So what's our second one in our second triangle going to be? Lemon? A. Yeah, it's going to be A. We're going from the 3 marks to the 2 marks. So here we're going from the 3 marks to the 2 marks. We're going along that side of the 1 mark as well. So that's L to A. And then our last one will be S. Hold on. Angle, I'm going to say angle B is congruent to what angle in our second triangle? Zach? Angle A. I didn't realize I used an A in both triangles. That's not good. So angle B in this triangle right here is congruent to the angle A in that triangle right there. What about angle L? What angle is that congruent to in our triangles? So angle L. Lena? Yeah, so angle L is right here, and that's got 3 marks. Angle A there has the 3 marks. I know. What's really nice about these congruency statements is that once you write this, you don't really have to look at the triangles anymore because these line everything up perfectly. Angle B is our middle one here, so it goes with angle A in this one. Angle L is our first one here, it goes with our first one here. So when I say something like AB, that's the side AB, is congruent to what side in our second triangle? Zach? LA. It just makes the congruency a little bit easier when we use those shapes. There are going to be some times where you're going to have to find some actual measurements. Take a look at this one. All right, there's your 2 triangles. Let's call this A, B, C, D, E. what's this? 2.5. I don't know. So triangle A, D, E is congruent to triangle B, D, C. Find the length of our missing side. What is the length of that right there going to be? Julian? 3? How do you get 3? So the distance from here to here is going to be the distance from here to here. Good. Yeah, this is just a reflection. So think of it as just like this line right here is your line of reflection. This triangle is being reflected over to that side. So that E matches up with that C. We can tell that right here. The E and the C line up. And the A and the B line up. The A and the B also line up. One other one that I wanted to look at. Sometimes they're not going to give you the angle itself. Triangle ABC is congruent to fill in that blank. So what is the congruent triangle to ABC? Brian? It is ADC. And if AB is 3, then what does AD have to be? Sammy? Yeah, it also has 3. Notice here that that congruency is just that 1. This also has the 1, so those two are going to be congruent to each other.
For the first one, like ABC congruent to ABC, it'd be like congruent to CDA.
The orders is what matters. So think of it like this. This angle right here is one angle. This angle right here is another angle, and then you've got a third angle right here. So that means that my A is blue, my B is orange, and C is green. This has to be blue, orange, green. It has to match up it has to match up in the same order. So that angle right there is my first angle, so that angle has to match up with my first angle here. This is my second angle, so it has to match up with my second angle here. In this, C is the same as C right there, A is the same as A right there, and D is the same as B. So that if this is first, this is second, this is third, then this has to be first, second, and third in our other triangle also. Yes?
So what you're saying is if you switch the first one, ABC, to CBA, then you also have to switch the other one to CBA?
Exactly, yes. If you switch those letters around. Think of it like this, like if you were to put these triangles on top of each other, they would have to match up. So if you had clear paper and you put a piece of paper here and you folded it over, those two would have to match up exactly. Now because those match up this way, that center angle matches up with that angle right there. This triangle is the same as this one. And yes, if you flip the order of those, then the order of your triangles would change.